All right, so here we have, this is an optional video. This is stuff that you've already learned. But if you're feeling like you're struggling with the assignment that you are working on, or if you feel like you just want to look at a few more examples, I've got 5 more examples of problems where we're going to be converting between masses, moles, molecules, and atoms of different compounds. So let's just look at the very first one. It says, how many atoms of magnesium are there in 83.9 grams of magnesium? So just like what we talked about the other day, the map that we use is you go from grams to moles, or vice versa, using the mm, the molar mass, and then you can go from moles to, in this case we're just going to put particles, and sometimes those particles are going to be atoms, so sometimes atoms, but if it's not an atom, then it's a molecule or something like that. If it is a particle and it's a molecule particle, then you can go from particles to the actual atoms, atoms, as well. Now, as I said, as you go from grams to moles, you use the molar mass. To go from moles to particles, you use Avogadro's number. And then to go from particles to atoms, again, if it is a molecule, then you use the chemical formula, CF. So in this case, they're asking us about atoms of magnesium. Now notice we don't have a molecule. We're only talking about magnesium. So when we get to particles, that's going to be in atoms already. We don't have to go from molecules to atoms because there is no molecule. It's just magnesium all by itself. So if we've got our 83.9 grams of Mg, the first thing we're going to do is we're going to convert from grams to moles using the molar mass of magnesium. So we go to the periodic table. The molar mass of magnesium is 24.3 grams, and that's the mass in 1 mole of magnesium. Now you'll notice that our grams of magnesium are going to cancel. And now that we have moles of magnesium, let's continue from moles straight to particles, in this case atoms. So now we can say we want to cancel our moles. So 1 mole of magnesium contains Avogadro's number, 6.02 times 10 to the 23rd. And in this case, because it's an atom, it's atoms. So now we can see that our moles of magnesium cancel each other out, and all we have left are atoms. So when we do the math here, we've got 83.9 divided by 24.3 times 6.02 exponent 23. And so for my final answer with 3 significant digits, I'm going to round that to 2.08 times 10 to the 24th atoms of magnesium. So again, back to our original question. If you got about 84 grams of magnesium, that's how many actual atoms of magnesium you would have in that sample, which seems like a lot. That's a great big number, but remember, atoms are really, really small. Okay, example number 2. What mass of sodium chloride contains 2.67 times 10 to the 23rd molecules of sodium chloride? Now in this case, again, think about where you're starting. We got grams, moles, particles, and then if that particle is a molecule, then we have atoms. Think about where you're starting and where you need to get. They want to know what's the mass of NaCl. This is where we want to get to. And we're starting with molecules, and so our molecules falls under a particle. So we need to go from particles to moles, and then from moles over to our grams, using the information that we already know. So we're going to go 2.67 times 10 to the 23rd molecules. And then we want to cancel molecules. So the conversion to go from particles to moles is using Avogadro's number. 1 mole equals 6.02 times 10 to the 23rd, whatever. So in this case, we have molecules. So we're going to go 6.02 times 10 to the 23rd molecules in 1 mole of NaCl. And then our molecules are going to cancel out. Now we have moles, so now we're here. Now we're going to go from moles to grams, and the way we use that is we use the molar mass of sodium chloride. So now we're going to our periodic table and we're figuring out the mass of NaCl. Sodium's 23, chlorine is 35.5, so the molar mass is 58.5 grams per mole. And again, if we want to cancel our moles, we're going to put our 1 mole on the bottom, and we're going to put 58.5 grams on the top. And now we're going to do our math. So we're going to take 2.67 exponent 23 divided by 6.02 exponent 23, and then we're going to multiply it by 58.5, and I get a final answer of, with 3 significant digits, 25.9 grams, because our moles cancel here, of NaCl. So that means that if you have that many molecules of it, that's the amount that it would weigh, about 25 grams of sodium chloride. Okay, third one. How many atoms of sulfur are there in 4.23 moles of Al2SO43? So again, think about where we're starting and where we need to get. Grams, moles, and notice how that time I wrote moles without an E on the end. Sometimes you will see that, is you will, instead of writing with an E, sometimes they don't. And so in this case, think about where we're starting and where we need to get. They want to know how many atoms. And since we have a molecule, notice I didn't even write particle there, I just wrote it as a molecule. So we've got molecules, so we need to get to atoms. How many atoms are there in this many moles? So we're not even going to use grams in this case. We're going to go moles to molecules and molecules to atoms. So if we've got our 4.23 moles, again, notice that MOL, sometimes it's written that way. We want those moles to cancel, so we know that 1 mole of Al2SO43 contains 6.02 times 10 to the 23rd molecules. That says molecules, I promise. And then we go to our molecule. So now in Al2, remember to go from molecules to atoms, we use the chemical formula. So we go to Al2SO43. How many sulfurs do we have in that one molecule? And hopefully you can see that this 4 only goes to the oxygen, does not go to the sulfur, but the 3 outside the parentheses does go to the sulfur. So we can say that in one molecule of Al2SO43, there are 3 sulfur atoms. And so now we are done. Our moles cancel, our molecules cancel. So we're going to take our 4.23, we're going to multiply it by 6.02 exponent 23, and then we're going to multiply it by 3. And we get a final answer, 7.64 times 10 to the 24th sulfur atoms. Now, sometimes you'll notice here that I did use the term molecule for Al2SO43. Technically, when we use the term molecule, we're talking about non-metal. We're talking about covalent compounds with only non-metals in that. A lot of times when you see something with a metal in it, instead of calling it a molecule, sometimes you'll hear the word a formula unit, which is even longer than molecule, but really it is just atoms that are bonded to each other. So technically it's not supposed to be called a molecule, but a formula unit really is just a molecule when you have a metal with nonmetals. All right, our next example says a 62.6 gram sample of chromium-3 nitrate contains how many molecules of chromium-3 nitrate? So again, notice I'm using that term molecule there. when you could use the term formula unit, but I think it's easier just to remember it that way as a molecule. So I'm not going to go through the first part again. We're just going to do the problem. 62.6 grams of CrNO3,3. And now I'm thinking, okay, I've got grams. There's only one thing I can do when I have grams, and that's convert to moles. So now I need to use my periodic table, and I'm going to convert my grams to moles by figuring out the mass of CrNO3,3. And I calculate it as 238 grams per mole. So since I have grams on top, I want to cancel grams, so I'm going to go 238 grams in 1 mole. And then, just to save some space here, I'm going to try to fit that last part on there. So now I've got moles. And now I know to go from moles to molecules, I need to use Avogadro's number. So now I'm going to put 1 mole on the bottom, and on top I'm going to go 6.02 times 10 to the 23rd, and I'm out of space, but right here I should be writing molecules, because then my grams are going to cancel, my moles cancel, and all I have left is what they're asking me for, molecules. So I'm going to go 62.6. I'm going to divide it by 238, and then I'm going to multiply by 6.02 exponent 23, and I get a final answer of 1.58 times 10 to the 23rd molecules of CrNO3,3. And that is my final answer for that one. All right, last one. This is not a tricky one, but just I'm trying to make them increasingly more difficult. So this is our last one. So this technically should be the most challenging one. It says, what mass of calcium nitrate contains 8.45 times 10 to the 24th oxygen atoms? So in this case, we're starting at atoms, and we need to get all the way back to grams. So think about our the little map that we have. We have atoms, and we need to get all the way back to grams. So we're going to start with 8.45 times 10 to the 24th atoms. And then we need to go from atoms to something else. Well, we don't have an atom. This is a formula unit or a molecule. And so what we need to do is we need to go from atoms back to molecules. So you need to look at this formula here and figure out how many oxygen atoms are in it. According to what I see right here, there's 2 NO3s, so that makes 6 oxygen atoms. So on the bottom, I'm going to put 6 oxygen atoms, and on the top, I'm going to put 1 molecule of, obviously, CaNO3,2. Now I'm going to keep going here. My atoms have canceled, and now I have molecules. So now I need to go from molecules. Think about your map about how we go. We're going to go from atoms, or from molecules to moles. So I want to cancel molecules. They're on the top. So I know that there is 6.02 times 10 to the 23rd molecules on the bottom, so they'll cancel, and that is equal to 1 mole of CaNO3,2. And so this molecule and those molecules are going to cancel, and then my final step is I've got moles of calcium nitrate. Now I just need to get grams. They want to know the mass. So I know that in 1 mole of CaNO3,2, now I need to go to the periodic table and figure out the mass of calcium, of 1 mole of calcium nitrate. Calcium is 40.1 plus 28 for 2 nitrogens plus 96 for 6 oxygens gives me a mass of 164.1 grams. And so now for my last step, I just simply have to do the math. So let's start at the beginning. 8.45 exponent to the 24th divide that by 6, and then watch, I'm going to hit the divide button again. I'm not going to hit times, or I'm not going to, I'm not going to hit times. I hit divide 2 times, so divide by 6 divided by 6.02 times 10 to the 23rd, and then finally multiplied by 164.1. So everything on the top I'm hitting multiply, everything on the bottom I'm hitting divide, and then for my final answer I get a response of 380, 4 grams of CaNO3. Now hopefully that's helped you out a little bit. I hope you get a little bit more understanding in that conversions from grams to moles, moles to particles, and then particles to atoms. If you have additional questions or would like some more sample problems, please come talk to me.